Hello and thanks for tuning in. This is Chris. In this video, I'm going to be teaching you how Kafka works with a live demo that's simulating an ordering system. So before going into the code and demonstrating the application's functionality, I wanted to go over some of the basic terms of Kafka, like the vocabulary. Sorry, there was a tongue twister there. Around Kafka and how it works in a real life scenario. So in Kafka, we have producers and consumers. So producers are they create the data that the consumer will accept and ingest and perform whatever tasks it needs to do. So as you can see on this diagram, a producer would be the ordering service because the ordering service produces items that represent, which could be anything. In real life, it could be food, it could be a package, it could be, more likely one of those two things. And we have the delivery service that listens for those events. Now, how that works, they listen to a topic. So a topic is basically how I like to describe it as a conveyor belt that handles specific, or that deals with a specific type of product, right? So in this example, we only have one topic, and that topic is orders. In a real company, you might have orders, you may have returns. There's different departments for that. Like if you go to a department store, there's a checkout, and there's a returns, and then there's a loss prevention, and there's a lot of stuff. But in this example, we're just using one. So another important thing to keep in mind when you scale Kafka, which is really the whole point of using Kafka is so you can handle these jobs in parallel. So that's when we come into consumer groups, and consumer groups are, or they are nodes that work together that take the messages from the topic and process them in parallel. So I'm trying to make sure you get this concept because it's confusing at first if you don't see, or if you don't tie it into a real life scenario. I know for me at least it's really difficult. So a consumer group is basically like a team inside of the company that works on a particular project. The topics only know about the service, not necessarily the individual nodes that's working on the service. So what you have to do in Kafka is add partitions, and partitions are, in my best way of understanding and explaining it, I should say, is they're like desks for multiple desks for an employee to work at. Because if you have three desks or three employees in one desk, only one employee can sit down and use and process the orders. But if we have three desks, now we have three people working in parallel. But when we send out, but when we're sending out an order to somebody, or when an ordering service puts the message in a queue, it doesn't really write to a specific node. It just writes to the delivery service. So the delivery service just knows about, and vice versa, it just knows about the ordering service, not necessarily how the ordering service or how the delivery service works. So that's just something that needs to be taken care of before running those processes in parallel. So hopefully that makes sense. So now I'm going to be showing you an example of how this works in the code. So I have written some Python code here that simulates an ordering system. So this is just some code that's making sure that I get a connection to Kafka, and then we are sending out orders in a burst using like a random time delay. So the really important thing to notice here is the partition variable. The partition variable, it used to be 0 because we only had one partition. But now, since we're planning on using 6 partitions to handle the orders in parallel, we need to let Kafka know that. So when we send out an order, we need to make sure we're writing that to whatever partition that we want to write it, that we want to process the order. So it's like putting somebody's name on a ticket and assigning them that ticket. So I know I did say that the ordering service doesn't necessarily know about the delivery service or the nodes in the delivery service. Now, this could technically that contradicts what I say in a way, but notice that I have to manually tell it that we have 5 partitions or 6 partitions. So that's what I mean by that. So technically it does know that there's a partition, but that's because I'm telling it that there are partitions by writing this in here. Now, this is not the way I would write this in a production or handle this in a production application, because partitions can change over time. But however, this is just to show you a quick demonstration. And back to the delivery service, we're simply listening to the orders topic, which we see here, and we are just simply changing the status of those orders as they come in. So right now I don't have any, so I destroyed our local environment just so I can start from scratch. So the first thing that I'm going to do is check our Docker Compose. So this is where I set my replicas for the microservices. And right now I have 2 ordering services and 3 delivery replicas. I'm going to boost that up to 6 because of our code. We don't have to use the full 6, but right now I just want to show you, just give you a concrete example of these working nodes running in parallel. And then we have a UI service, which is going to show us those orders in real time. However, I do prefer to look at the Docker logs because they just look more cleaner and they don't disappear like the table that I have in the HTML. But nonetheless, I can get started with that. So I'm going to run these commands that I've written down here in my document. So I know the first one is Docker compose build to get the containers up and running. Then I do the -d to escape out the terminal. Whoops. Docker compose up. So you just give that a second. Now I'm glad I'm doing this because I can show you before and after I increase the partitions, because right now if we verify we only have 1 partition, because by default we start with 1 partition on index 0. So you can see partition 0, 1 liter. So that's what that means right there. And if we go into our Docker, you can see our Kafka demo running. So if we click on that, so I think we're going to run into an error because we only have 1 partition. We're telling it that it has more than 0 or more than 1, but yeah, so unfortunately that's not going to work yet until I scale it. So let me just do it this way now, just to make it more cleaner. So we are going to start with partition 0 so we can see those logs populate in Docker. So now it looks like it's working. So we have our partition 0, we see order number 1. You see those orders coming in, being placed, and they're being processed by partition 0. So that means we have 1 worker node. Now, if we go back to containers, we can see that we have several of the delivery service nodes running, but they're not processing any orders. So there's the node ID, and it's listening for new orders, but it doesn't know about those orders, because that order that we talked about, if we go back in the code, it doesn't have its name on it, right? It doesn't have delivery service 5 or the partition number that it's assigned to. So that's what this is for. So I'm going to go back and change that from the partition 0 to selecting a random integer between 0 and 5, which gives us 6 numbers or 6 choices that we can, 6 partitions we can send orders to. Now after that, we are going to also increase the partition amount and then verify it. So this one has 3 partitions in it, but I'm going to change that to 6 just because we have the options. And then we can check the partition amount, and we see that we are using indeed the 6 partitions here, 0 to 5. Okay, looks good there. And then now we have to scale the delivery service. We already have 6 nodes, but I think we should just restart it. Just to be on the safe side, I wanted to scale it to 6. It's already doing, I figured. And also we're going to restart it just to rebalance the nodes as well. So just make sure that we're getting an equal distribution of this of the orders. Now, I don't know if that really is going to make a difference because we have the random integers selecting which partition it goes to, but regardless, let's go check out the Docker logs and see what's going on here. So if we go back to the Kafka demo, okay, so we give that a few seconds to see if there's more partitions working. So that's partition 0, delivery service 3, looking for the additional delivery service. Let's go to delivery service 4. Okay, it's not being used yet. I think I might be missing something. Okay, so let me go back. Scale, okay. Describe orders. Restart. Interesting. What if I stopped the service and restarted it? Okay. I'll go back. If that doesn't work, I'll just rebuild the Docker container. I think that's what I do need to do. That's the problem. I don't know if I don't even remember if I did that. But let me just make sure that the partitions are still saying 0, and then the other delivery services are just idle. Let me double check. Okay, so yeah, that's not going to do it. So I do have to rebuild it. But let me make sure that my replicas do match what I have currently so we don't. Okay, great. All right, so let me just do a rebuild. Okay. Just give that a few seconds. Just ordering service. Partition 2. Excellent. So now we can see that those partitions are now working. So before it was just lingering, and now we have partition 2 working, processing those orders. Partition 4 is processing those orders. Partition 1 is processing those orders. So that looks great. So that's it. And in the UI, we can also just see what that looks like. So if you ever went to a restaurant, if you've been to Panera Bread or I think most fast food chains have some type of, well, you know what? Yeah, they all do. They have some type of system like this. If you're working in, not all restaurants would show you your order in the queue, but I do know, like, if you worked in a fast food restaurant before, there are like screens that show the orders coming in, and there's multiple people making orders, and as they get delivered, they get popped out the queue, right? So we can add more people to the shift. We can call people in. We can tell them to go home early, or we can, that's really how it all works, and it's very similar to fast food. All right, so hopefully that makes sense. Did the best I can explain it. I know it's a topic can be a bit difficult to understand at first, especially if you haven't worked with distributed systems, but I try to make it easy for people just getting started with it, because using Kafka can definitely bring tremendous benefits to your software applications and and user experience too. So if you have any questions, you have any suggestions even to make this type of content better, feel free to drop a comment and see me on my next one. Take care.